All right, in this video, I'm going to go through the 2.b.i factoring quadratics DeltaMath assignment. So it's just our very beginning look into how to solve quadratics, and we have to be okay with factoring them first. So let's go ahead and try some of these first problems. Okay, so factor the expression completely. So the first thing you always check for in quadratics, or I guess in this case it's not even a quadratic, but if you're factoring, you want to look and see if there is a GCF. So any sort of number or variable that is common in all of your terms. So for example, this has an x and this doesn't have an x, so there's no variable that's common, but the number that's common between both of these is that both of these numbers are divisible by 3. So if I pull that 3 out front, here, let me rewrite the problem here. If I pull that 3 out front as the greatest common factor, to figure out what's left over, you can really think of it as doing the numbers divided by 3 to figure out what's left over. So 3 divided by 3 is 1. The x is still there, plus, and then 24 divided by 3 is 8. So your factored, completely factored, this is what your answer would look like. 3 and then x plus 8. To figure out if you did it right, you can always double check by distributing the 3 again and making sure you got what you started with originally. So if you would like to do that, you're more than welcome to. And obviously they give a really good explanation here. All right, let's try another one. So for this one, it looks like I have at least one x in each of my terms, and then there's no number that is divisible, or no number that goes into both 8 and 3. So I think the only thing I'll be pulling out is an x, but let's just double check real quick. So if I have an x out front, yeah, there's no number that goes into 8 and 3. 3 is prime, so it can only be divided by itself and 1, but 8 can't be divided by 3. So if I pull out the x, you figure out what's left over. Well, I took the x out of this piece, so I just have an 8 now, and then I have the minus 3, and then there were 2 x's here, but I pulled one out, and so I'm left over with 1x. And again, to double check your work, you can always distribute that x back in. There we go. All right, let's go ahead and do some more of these, but with slightly more difficult problems. So for this one, we have negative 6x to the 4th minus 27x to the 3rd. So first of all, right off the bat, I noticed that I have a couple of x's I can pull out of each of these. I have 4 here and 3 here, so the most I can pull out of both of my terms is 3. And then, are there any numbers that I can pull out? Well, I noticed that both of these numbers are divisible by 3. 27 isn't divisible by 6, so I can pull out, it looks like, well, negative 3 as well. I don't know how it's going to be with the negatives. I don't know if it's going to want you to pull them out as much as possible, but since I noticed that both of these are negative, that's what makes sense to me. Let's go ahead and figure out what's left over, and then we'll see if DeltaMath likes us. So if you are trying to figure out your numbers, remember, you can just think of it as dividing by whatever you pull out, by the negative 3 here, and then we'll deal with how many x's are left. So if I do negative 6 divided by negative 3, it gives me a positive 2, and I took out 3 x's, so I have 1 left for this first term. Then I did negative 27 divided by negative 3, which gives me a positive 9. And then I took out all 3 of those x's. So this is actually my answer. All right, let's see what DeltaMath wants to do with us. Okay, I picked. Negative 3x cubed, 2x plus 9. Oh, yep, so if they both are negative, I guess it wants you to pull out the negative, so. All right, let's go do this one now. So for this one, we got negative 9 plus 45x cubed. Let's see, they don't both have x's in them, so I can't pull out any variables, but 9 and 45 are both divisible by 9. Again, I'm not sure if it wants me to pull out the negative or not. I'll try not to this time. We'll figure out what happens. So if I pull a 9 out, to figure out what's left over, again, for numbers, you can just think of it as dividing by that number. So negative 9 divided by 9 gives me negative 1, and then plus, and then 45 divided by 9 gives me 5, and then that x cubed is still there. Let's see if that did it for us. Yep, it's fine with that. So I wouldn't really worry about pulling out a negative unless they're both negative then. That's what we've confirmed. All right, let's go ahead and do factoring with trinomials now. So that was a lot of practice with your GCF, but now the real part for quadratics is that you have to be able to factor trinomials. And so we taught you in Algebra 2 a method for doing this, right? You figure out what numbers multiply to AC and then add to your B value if you have a little more space. If you have a quadratic that says ax squared plus bx plus c. So in this scenario, in this problem, I have x squared plus 3x minus 70, which means that my a is 1, my b is 3, and then my c is negative 70. The goal eventually for you guys would be to not have to depend on using this table to actually write it out. But for now, we'll start off with that. So 1 times negative 70 is negative 70, and then b is your 3 value. So you're thinking, what numbers multiply to negative 70 and add to 3? Oh, wow, there's going to be quite a few of things that we have to work through. So like, for example, you could start off with like 35 and negative 2. Definitely don't add to 3. You could do, let's see, 5 and negative 12. Nope, that's 60. 14, 5 and negative 14. Definitely don't add to 3. So sometimes it might take you a little bit to figure out what numbers multiply to AC and add to B, but eventually you can get there. So like, for example, positive 10 and negative 7. Multiply to negative 70 and add to 3. So my factors for this one would be, stop it, x plus 10 and x minus 7. And that's all it wants you to do here. It just doesn't want you to solve anything, it just wants you to factor. Cool. They set it up in like this crazy way where they have this x instead and we use this table, but either way, it's good to go. All right, for this one, let's try not to ruin my table too much. I failed. All right. And again, eventually we'd like to get you to not use this table and just ask yourself mentally what the question would be. So I got x squared minus x minus 2. So that means that a is 1, b is negative 1, c is negative 2. Wow, got a lot of stuff going on over there, negative 2. So AC is negative 2, b is negative 1. So what multiplies to negative 2 and adds to negative 1? Well, that would be, let's see, negative 2 and positive 1, I think, right? There's only a couple of things that multiply to negative 2. So then your factors for this one would be x minus 2, x plus 1. Voila. All right, let's try one more. And I think you get the gist. All right, oops. For this one, we got x squared minus 12x plus 36. So if we're multiplying to, I'm going to try to write it without the table. A, B, C. Okay, so we're trying to multiply to AC, so we're trying to figure out what multiplies to 36 but adds to negative 12. What multiplies to 36 and adds to negative 12? So we could do, let's see, 12 and 3, both negative. Nope, that won't work. We could do 4 and 9. Oh, that's close. They both have to be negative. Let's see, aha, 6 and 6. But they both have to be negative because they have to add to negative 12, but they have to multiply it into positive 36. Oh, geez. Voila. Cool. So that's how you do these problems. If you have any questions, let me know.